All right, before we get started with our introduction to programming with C#, we wanted to take just a moment and go over some of the general programming terms that you're going to hear often. As a matter of fact, you may recognize a lot of these terms as we've been using them throughout video number 1 all the way up to video number right now. So here's what I want to do, Logan. I'm going to say one of these terms to you, and I want you to tell me what comes to mind in just regular, plain English. Nothing complicated, just plain English. So let's start off with a programming language. What is a programming language?
Well, a programming language is what's used to bridge the gap between the way a person thinks and the way a computer thinks.
Okay.
A computer processes and thinks in binary, in ones and zeros.
Okay.
And a person thinks in terms of words. So what a programming language does is it's something that is structured so that it can be turned into computer language, but it is descriptive so that a person could read and understand it.
Gotcha. Now, you use ones and zeros. In essence, that's all the way down at the hardware level, right?
Right. That is ones and zeros, that it's binary instructions that a CPU could simply process and run.
Now, we're not quite as old school as we used to be. Back in the old days, that's how we had to program. But nowadays, we're not necessarily talking directly to the hardware, right?
Right, because that would make simple tasks take a long time.
Okay.
If you had to write everything instruction by instruction, for one, it'd be cryptic, so it'd be hard to keep track of what you're doing.
True.
And for two, it'd be very hard to reuse code, because every time you wanted to use an instruction, you just have to continually reuse it. You wouldn't have any larger library you could pull from. You would have what the CPU understands, and that would be it.
So nowadays, it's more talking directly to the operating system or some sort of infrastructure that's sitting on top of it to perform off tasks at a lower level in which that system that's sitting on top of the OS or the OS itself is going to handle doing for you.
Right, that infrastructure can give you a lot of interesting abilities, but then it can then turn those around and turn them into simple machine code that the CPU can run.
Okay. Source code.
Source code is simply the code you will write when working within a language.
Okay. Simple enough. Now, we've seen a lot of source code. I mean, the Hyperion project, we've created all sorts of files containing source code.
All that we typed out was source code.
Okay. Object-oriented programming.
Object-oriented programming is a method of programming where functionality and data can be organized into separate units.
Okay.
Such that, and those units are called objects. That way we can divide things up and think about things more like we do in the real world. When we think about a toaster that has some properties like how heavy it is and has an action, that is to cook toast, we can take our code and divide it up into objects, so that way we don't always have to work with individual values. This was again seen in Hyperion, where while rooms had data in them and they had functionality, we could still look at the room as a unit and even take that room as a whole room and pass it to something or store it in the level. Okay.
And we also did that with the items as well. As a matter of fact, we saw how we could take an object and create many of that type of object, being mini rooms in a level. And we also saw how we could create static objects where the game manager, we only needed one of that particular object type. But in the end, doesn't this really just simplify problem solving?
It simplifies problem solving, it allows us to organize code, and it also allows us to much more easily reuse code, because once we put a bunch of code into a unit or a class, we can then call on that class by just enacting one of that class, instead of having to maybe enact all 50 types of data or members it may contain.
Okay. So moving on from object-oriented programming, as we're going to be spending a lot of time with that later, let's talk about compiling.
Well, compiling is the process of taking your source code, which you have written in a specific programming language, and actually turning that into code that the computer understands, either that the computer understands or that the framework you're running on understands. But simply put, it is the process of turning source code into binary code.
Okay. Interpreted or interpreter?
That's another method of using source code, where a compiler would turn your source code into something that the computer can just understand and run. An interpreter takes your source code and runs it itself. Generally, that means that your code is more or less run by a program more so than by your computer.
Okay.
It's where that program takes your code statement by statement or line by line and runs it and produces some result based on that source code. So there's never a binary compiling step involved.
So obviously with an interpreter, things are generally slower than if you had a compiled program.
Right, because again, you have to run, it's being run in software instead of hardware, if you want to think of it like that.
Well, let's pretend you speak another language than I do, and you and I need to communicate back and forth. If I simply understood your language, that would be real fast, but if we had to bring in some sort of translator to interpret what you're saying to me, then things are going to slow down.
Right, that interpreter would have to think about what I'm saying and then say that back to you. So you have the step of it being spoken twice, as well as the step of the interpreter having to figure out what is being said.
It's known as the middleman. All right, very good. Moving along from there to execution, or running.
That's simply the process where you take either lines of code or computer instructions and tell the computer or the execution environment to begin running them.
Okay. So if it is, of course, a compiled application, it's been compiled to native code, then the OS will handle actually executing that application. Let the code do its thing, right?
Right. It basically gets thrown into the pipeline, so to speak, where you give it the program and tell it where its first instruction is, and then execution continues on from that point.
Okay. Or if it's being interpreted, then the interpreter comes in and starts executing line by line so that you have a running program.
Right. And then that program continues to run until it's otherwise told to quit.
Okay. Functions.
Functions are a way of grouping individual statements or individual pieces of functionality, where you can have a complex series of things happen, but then package all that into one simple module of code, which is called a function, so that we can call upon one function but have multiple things happen.
So that function generally has a very specific purpose, correct?
Right, and then that's generally the idea, is that you have a specific purpose for that, but that purpose involves carrying out multiple actual actions.
Okay. Now, we're not going to hear the term functions thrown around a whole lot during this C#/XNA course, because functions are actually known as methods. It's a function within an object. So the method is a member of a particular object. So you guys are going to hear them being referred to as methods. From there, let's talk about variables for just a second.
Well, a variable is a way to name, store, and retrieve a piece of data.
Okay. So basically, it's a place in memory that's holding some sort of information that we can get back to.
Right, we can get back to it by name.
Okay. Debugging.
Debugging, simply put, is the process of finding, analyzing, and correcting problems or bugs within your program, within your application.
Okay. And Visual Studio provides for us debugging tools to help make that process simpler.
Right, not only finding, but giving you the ability to analyze how your program is running while it's actually running.
Okay. Data and data types.
Well, data simply refers to the action or the act of storing information inside of a computer. Data types are what allow us to take individual pieces of information and represent them with a type that makes sense to us, meaning that you can have something like an int and a float inside of a computer. They could even be the same size within the computer, but the type tells us how we are to interpret that data, where an int we should look at that as a whole number, and a float we should look at as a decimal number.
Okay, or perhaps a bool that's going to hold like true or false, or a char that's going to hold a single character.
Or even an entire class or object.
Ooh, that's right. Again, moving us back to when we were talking about rooms and items in the Hyperion project, we represented those objects in variables.
That's right.
Okay? Garbage collection.
Garbage collection implies that there is some form of manager that follows your application as it's running, and that manager's job is to look at the data that has been created through variables or otherwise and decide when those objects are no longer used. And when they're no longer used, its job is to clean them up so that they don't continue using memory.
Okay, so let's say, for instance, we were working in C++, now that we've been talking about objects a little bit, and of course C++ is an object-oriented language. I could create an object, and that object, let's say, I forget to dispose of it, because it's my responsibility over in C++ to dispose of that object when I'm done. If I don't, it's just sitting out there eating up memory. And if another object of that type was created and another one was created, but they were never getting disposed or getting killed off, we basically have a memory leak, right?
Right. It's possible and very easy to lose references to objects. If you create something and then don't remember where that object is, it still resides there. Even though you can't get back to it, it's still taking up memory.
Right.
In the case where you have garbage collection, you could do that same thing, but then the garbage collector will notice the fact that you have discarded some piece of information, and it will go and actually take it out of memory and dispose of it.
Once it determines that that piece of information is no longer going to be used.
Right.
All right, and of course with garbage collection, there is no way of predicting when it's going to come by and get rid of said data. It's just...
Right, it's just something that operates on its own time as your application is running, whenever it sees fit.
Okay, so there are some general programming terms that you guys are going to be using yourselves quite a bit throughout this course. You're going to hear us saying these things as well. And a lot of these different terms are going to get broke down in actual lessons coming up here very soon. So with that, that is going to wrap up this video on general programming terms.